Hello. So today we're going to look at sector area. A sector is kind of like a slice of pie or a slice of pizza. I like pizza better than pie, so I'll say pizza. So imagine that from the center you cut off two radii and you take that section or sector out of the pizza. Okay? So we want to know though, what is the number of square units that will be left over? Well, how can we find that out? Well, if I asked you what's the area of this whole circle, you would be able to find that, right? You would just do area of a circle will equal pi times the radius squared. And that's all you would need. But for a portion of the circle, just a fraction of it, how could you find out what the area would be? Well, that's right. You could just multiply it by what fraction it is that we're looking at. Well, how do we do that? In this case, I know that this is 60 degrees, but I want to know what the shaded area is. How much would the shaded area be if this portion is 60 degrees? That's right. If we take 360 being the entire circle, and subtract the 60 away from that, we'd be left with 300 degrees. So we only have 300 degrees out of the 360 degrees that we want to look at. And as you said, to find the area of just that portion of it, we would multiply that times pi r squared times the area of the whole circle. Well, let's see. A normal pizza has a radius of about 8 inches. So we'll say the radius is 8 inches. And so in doing so, we end up with 300 out of 360 times pi, 8 inches squared. And when we do this, we end up with this fraction reducing down to 5/6. So we get 5/6 times 64 pi square inches. And of course, I can reduce that further if I would like to. And I get 160 over 3 pi inches squared, which is approximately 167.55 square inches. Okay? That seems like a lot of pie, or a lot of pizza. Pizza is pie, to me at least. Anyway, so the area of the circle will just be pi r squared, but before we're looking at a portion of it, we need to know what fraction of the circle we're looking at. Well, how do we find out what fraction we're looking at? We take the number of degrees that we have in that sector divided by 360. This should look kind of similar to arc length, which it does. With arc length, we looked at the angle divided by 360, the central angle divided by 360, and we multiply that times the circumference. But in this case, we're talking about a sector area. We're going to take the central angle divided by 360 and multiply it times the area of the whole circle, pi r squared. All right, let's look at another example. So I'll pause. Okay, I want to find out what is the area of this region here. And I know the number, the central angle for that area is 127 degrees. So I need to find the sector area here. And from what we just talked about, sector area would be the number of degrees, or the central angle, that's given, out of 360 times pi r squared, which being the area of the entire circle. Okay, so for this example, I would have the sector area is equal to 127 degrees out of 360 times pi times 6 meters squared. Now from here, I could just put this into my calculator, or input this into my calculator. And I end up with 127 over 10 pi meters squared, which is approximately 39.90 square meters. And that's it. The central angle, which is given to you, divided by 360, times pi times the radius squared, because that's how you find the area of the whole circle. And that's all there is to it for sector area. You're just looking at that section of the entire circle, that sector of the entire circle. So find out what fraction of that you have and multiply it times the area of the whole circle. And that gives you sector area. Okay, so that's sector area. Now let's see what happens when we look at one other thing. Let's say we know this central angle is 120 degrees. And let's say this chord cuts it. Okay. Remember, a chord is a line segment that goes from one whose endpoints are on the circle. So it goes from one point on the circle to another straight line segment. Let's say that we want to know what is the shaded region. How do we find that? It's not a sector, but it's a part of a sector. And it's not its own circle, it's a part of the same circle. How do we find that? Well, if you remember from parts, when we talked about parts of a circle, this is called a segment. And we'll discuss how to find that soon enough.